Here we're given an equation to solve, and it involves modulus, and we're told how to solve it. We're told to use this identity. So rather than taking positive and negative, it looks like the question is suggesting that we use the trick of squaring both sides. So we take the left-hand side and we square it, and we take the right-hand side and we square that, and we make them equal to each other. That's one way of dealing with the modulus function. So now we have something that looks almost like a quadratic, because we know that we can use this identity and we can somehow remove cosine squared or sine squared in terms of the other. So let's first of all, because we know it's going to be a quadratic, let's try to make it equal to 0. And we'll do that by moving the cosine squared to the left of the equal sign. And then if we rearrange this identity, that gives us cosine squared x equals 1 minus sine squared x. And we can take that and replace the cosine squared. So now we have an expression that has only sine squared in it. So it's a quadratic expression. We're able to solve that. So if you multiply the minus 1 by both of these, you can remove the brackets, and the minus becomes positive. Sine squared and sine squared becomes 2 sine squared. Then you can move the minus 1. You have an equation where you can easily solve it. Divide both sides by 2, then take the square root of both sides, remembering to take both positive and negative answers. So now we have something that's familiar and easy to solve. You simply take the sine inverse of that, but you need to do it twice. You need to look at the positive and the negative versions. So if you take the inverse sine of 1 over root 2, you get 45, and when it's negative, you get negative 45. So that's your final answer, except we were told to find all the solutions in the range 0 to 360. So there's another 2 solutions we need to find. So if you subtract that from 180, you get your next solution. And if you subtract that from 180, you get your 4th solution. So there are 4 solutions in total. So 1, 2, 3, 4. This one isn't in the range, so we need to do something about this. So this solution isn't acceptable. So we need somehow to fix that. So what you could do is simply add 360 to that. So that'll give you 315, and that is in the range. So now we have 4 solutions. They're all in range. So 45, 135, 315, and 225. So that's your final solution. We answered this by squaring both sides to get rid of the modulus, and then using the identity they gave us to eliminate the cosine squared in terms of sine squared.